So right away, we have 5 more to get because we already have cotangent given to us. Tangent is free because it's just the reciprocal of cotangent. What I'm going to do now is I'm going to look at my basic identities and find one that involves cotangent or tangent and then sine or cosecant. So I'm going to go with P2 that says 1 plus cotangent squared is equal to cosecant squared. Negative 5 over 9 squared is 25 over 81, plus 1 is 106 over 81. Square root both sides gives me plus or minus square root 106 over 9. And because sine is negative, I know that cosecant also has to be negative because they're just reciprocals. So there's my third. And then I get sine for free from that. So after I rationalize my denominator, I get 9 root 106 over 106. So far, so good?
Oh, yeah, of course.
Okay. The last thing I have is cosine and secant. So I'm going to use the fact that cotangent is equal to cosine over sine. If I multiply both sides by sine, I have that cosine is equal to sine times cotangent. So if I plug those in, I get that cosine is 5 root 106 over 106. And then secant is just the reciprocal. So after I reduce, I have root 106 over 5.
Okay, yeah, that makes sense. Thank you. Thank you. I appreciate it.
Sure. In general, I end up using a Pythagorean almost always right away because it's going to be that's the positive or negative part is going to tell me whether I want the plus or minus when I solve.
Yeah, exactly.
And then probably a quotient to finish it out.
Okay.
Paul, do you have a hand or no? How is what?
Sorry, getting my words right. Negative 5 over 9 squared. Like, I don't know. I just think of negative 5 over 81.
So that's 25 over 81, right? Positive 25.
Square the top and the bottom.
Right. And then when I make a common denominator with the 1, I end up with the 106 over 81. And then when I square root both sides, I have the square root 106 over 9.
Okay, that makes sense.
I skipped some of the computation because it's, you guys should be good with that. Aria. Sure. So here we have really only 4 more to get because we're given 2 of them in the problem, right? Since I have secant, immediately I get cosine because they're just reciprocals. Reciprocal of 1 is 1. I can use then P1, sine squared plus cosine squared is equal to 1. So sine squared is equal to 0, and the square root of 0 is just 0. Cool with that. From that, I get immediately cosecant because they're reciprocals. The reciprocal of 0 is like 0 over 1, or I'm sorry, 1 over 0, which is undefined. And that's my insight that I needed to figure out what to do with cotangent. So notice that sine is 0 and its reciprocal is undefined. Since cotangent is undefined, it tells me its reciprocal must have been 0. So that's all. Aria, are you okay with that?
Yeah.
So probably the observation that 0 and undefined are reciprocals was the trick there that we weren't sure about. But if you made that realization, everything else kind of flows pretty naturally from there. Amanda. Sure. I think this is the trickiest one because if you don't make the same algebraic first step, it turns into a mess. So again, I typically suggest starting with an algebraic, looking for algebraic things to do. So there's two possibilities, two algebraic things to do here. You could make common denominators to add the fractions, or you could take a greatest common factor of tangent. That's the one that I would do. And the reason I would do that versus making a common denominator is that when I factor that tangent out, I can see that I'm going to be left with 1s in the numerator for my fraction. And then I can apply my reciprocal identities right away to get rid of the fractions, and I don't have to worry about common denominators at all, which is what I'd prefer to do. No fractions is definitely easier than fractions, right? So using my reciprocal identities, I notice that 1 over cosecant squared is just sine squared. Similarly, 1 over secant squared is cosine squared. And then sine squared plus cosine squared, I see right away. What's that? 1. And 1 times tangent is just tangent. And once we've gotten down to a single term, can't do better than that. So we're done. Amanda, does that feel okay?
Yeah.
Did you have like a half a page of doing something else? Yeah, this can get really, really bad if you didn't factor the tangent out as your very first step. If you tried to go all sines and cosines or try to make common denominators, things get bad quick. Hi.
Oh, thanks.
You're welcome. Maddie Frazier. Looks like you're leaving. And in general, Amanda, I think that's a useful lesson that if things start getting really, really bad that quickly, there probably was an easier thing to do earlier on. Now you can keep going the way you're going, and eventually you'll get to the answer if you're doing everything correctly. But if it's been like 4 or 5 steps and there's like no end in sight, it might just be a let me just start over and try something different in the beginning sort of situation. You know what I mean? Because these shouldn't be like a half a page problems. Most of them can be done in just like a couple of steps like this. Fair enough?
Yeah.
Just for some advice. Luke. Sure. So if we take a look at 14 and we look for anything algebraic to do, there's just really one option. You need a common denominator and add these two fractions, right? There's nothing else to do algebraically. And in fact, there's nothing really to do identities-wise. I mean, you could write the sines as 1 over cosecants, but that doesn't feel like it's making life any better, right? So looking at these two, what would the common denominator be?
So for 1 over 1 plus sine of x, you multiply that by 1 minus sine of x over 1 minus sine of x.
I don't know if you just misspoke or if I misheard, but we want to do that to that one and this to that one. Okay. I don't know. I can't. It's the end of the day, man. My brain is mush. You guys get it. But that's what you need to make. Your common denominator is just 1 plus sine y times 1 minus sine y. Everybody agree? There's nothing. They're relatively prime. There's no common factors between them. Okay, so I'll multiply the 1 through. Well, that just gives me 1 plus sine y. And then I'll multiply the 1 through, and that gives me 1 minus sine y. And my denominator is 1 plus sine y times 1 minus sine y. Okay. I see a whole bunch of algebraic stuff that we could do. In the numerator, I have a bunch of like terms that can combine, right? I have a positive sign and a negative sign. Those guys add together to give 0. I have a 1 plus 1 left, so that's a 2. And because my numerator now contains no trig terms, obviously I'm going to have to FOIL that denominator out and hope that something better comes out of that, right? There's no sense in leaving it factored since there'll be nothing to reduce it with. So I'll FOIL that out. And really, rather than FOILing that out, I observed that that's a difference of 2 squares. So I just used the factoring pattern to shortcut to the a squared minus b squared. If you FOILed it out, it's not the end of the world. It's like an extra step. So far, so good? Okay. So the only place for improvement here would be if I can somehow take this 2 terms and turn it into 1 term, right? The obvious place to look if I have 1's addition or subtraction and then something squared is the Pythagoreans. So what do you say there? Yeah. So you can make that substitution directly. What Luke is saying is that sine squared plus cosine squared equals 1. I can just subtract the sine squared from both sides. So that I can say cosine squared equals 1 minus sine squared. Or if you wanted to, you could just take the 1 and replace it with sine squared plus cosine squared and add the cosines and everything cancels out. You could do it that way too. It's doing the same thing. It doesn't matter to me which way you think about it. But that's the next appropriate step, which is great. Now we have one thing in the numerator, one thing in the denominator. The only improvement we can make from here is if we can get rid of it, get rid of the fraction, right? So the way that I would think about this would be 2 times, and I need a parenthesis, cosine squared over, or 1 over cosine squared. And I like doing that because now it's in the form to use one of the reciprocal identities. So 1 over cosine squared is just secant squared. And that's as good as we can do. Again, it's not down to one thing. It's the product of 2 things, but one of them's a constant. So, like, what are you going to do? Not any better than that. Is that cool? Okay. Amanda. We haven't assigned worksheet 1 yet.
Oh, my bad.
That's okay. So I'm just gonna table that. Totally fit. We're gonna do it eventually. The fact that you've started it, not a big deal at all. But probably at one point it was like marked as something that was probably going to be due. But I just, trying to make the homework load manageable, decided to just go and push it till after break kind of thing. Because it felt like a good idea after a week off to just be like, hey, let's do these things in class and we can work on these things that you haven't done or thought about in a week. So that felt better than like trying to cram it all down your throat before we left. You know what I meant? That was my reasoning anyway. So probably at one point I had planned on it with there still being 2 days next week, but now that there's a week, it just feels like we'll leave that for next week. Jordy.
Did you say Jordy?
Yeah.
Okay.
Do you not like that?
No.
Oh, my apologies.
My mom put it in because it asks for nicknames.
And it says not Jordy.
Yeah, and I thought you did it as a joke. No. Never mind. Okay. Can you re-explain?
If I ever call you something that you don't like, you're entitled to ask me not to do that.
Okay.
So Jordan.
No, I just thought you were doing it as a joke.
Oh, I wouldn't. I mean,
Okay, can you?
I don't. You didn't laugh. I don't know who's funny. Anyways, I'm sorry. We're embarrassing each other now. I'm embarrassed. I'm turning red. Go ahead.
Can you re-explain 5?
Yeah, we can talk about 5. Okay. So looking at 5, initially I'm going to look for an identity to use. Okay? Because I have something as positive or negative, the identity that I'm going to be looking to use is going to be a Pythagorean. Because when I square root both sides, the sign being negative is going to tell me whether I want the positive or negative. Okay with that?
Mm-hmm.
The other piece that I know is cotangent. So I'm going to look for an identity, one of the Pythagoreans that has either cotangent or tangent, because they're reciprocal, so I know about that, and I should say sine or cosecant. Again, if I have sine is negative, I know cosecant is negative too, because they're reciprocals. So the one I went with was P1, which is 1 plus cotangent squared equals cosecant squared. So that's the first line that I wrote here. Okay with that? I've just filled in the negative 5/9 for cotangent.
Yeah.
So far, so good?
Yeah.
Okay. So I just combined my like terms on the left-hand side. 1 plus negative 5/9 squared is 106/81. And when I square root both sides, I get plus or minus square root of 106 over square root of 81. And the square root of 81 is just 9. So that's where the denominator 9 comes from. So this was just me adding fractions and then taking the radical and reducing. Okay or no? You're saying okay with your mouth, but your face is saying not okay. So I'm not sure which to believe.
I'll figure it out.
You can just so negative 5/9 squared is 25 plus 81, right?
Yeah.
Or 25/81. Make a common denominator, right?
Right.
Add fractions. So I have 106/81 equals cosecant squared.
Got it.
Square root both sides. Square root of 106 is 106. Square root of 81 is 9. And it's plus or minus because I had to square root both sides. Is that okay?
Yeah.
Okay. I can discard the plus from the plus or minus because sine is negative, so cosecant is negative. You cool with that? Okay. So since I have that, sine is its reciprocal. So I flipped it and then rationalized the denominator. So I had negative 9 over square root 106, and then I had to multiply the top and bottom by square root 106. Is that okay?
Yeah.
Okay. And then the last part, I said, okay. Now looking at this, I have... Ugh. I hate you, stupid machine. Oh my God.
Well, it hates you too, Mr. Cooler.
I'm glad. I'm going to go to war against that. So we have tangent, cosecant, sine, and cotangent, right? Those are the 4 that we figured out. So what I'm going to do is I'm going to look for any identity that involves 2 of those and then either sine or either cosine or secant, since those are the 2 pieces that I haven't figured out yet. Okay with that? I settled on Q2. which is just cotangent equals cosine over sine. To get the cosine by itself, I multiplied both sides by sine. Okay with that? And then I just plugged in my value for sine and my value for cotangent and simplified. That gives me my value for cosine. Cool? And then for secant, I just flipped cosine and reduced. Is that?
Yep.
Okay.
Yep.
So in general, the pattern here, Jordan, is I typically start with one of the Pythagoreans, whichever one works with the information I'm provided, get as much as I can out of that, and then typically I'm going to end with one of the quotient identities. Once I have 4 out of the 6, really any of the quotient identities will work. It's just about choosing one that makes the algebra kind of convenient. But any of them are fine. Okay? Sure. Anybody else? Okie dokie. Let's do 5-3. So section 5.3 is about proving identities. So when...
Did we already do the rules?
Oh, did we do this already?
Yeah.
Oh, righteous. Okay. Never mind then. Thank you. Any more questions then from homeworks? So we assigned all the way to 62 then, right?
Yeah, but we convinced you to move it.
Yeah. That's fine. Like none of it's 1 through 30, but this Sunday.
Yeah.
Everything else 2 Sundays from now.
After break.
After break.
Nothing to do over break.
Nothing to do over break. So first Sunday, stuff due. Next Sunday after that, nothing. We come back, we do a week of class, stuff due again. Nothing due Thanksgiving weekend. Enjoy your Thanksgiving. Try to stay in a turkey coma the whole time. Okay. So we're good. Questions resolved?
Resolved.
All right. Let's do this homework quiz. Find a partner. Once you've found a partner, come up and get a quiz for me. Hi, Amanda. Who's your partner? Okay, take 2 of those sheets. Hi, Aria. Who's your partner?
Emma. Oh wait, why am I taking it?
You take 2 of those too.
Oh.
Yep. Who's your partner?
Emma.
Okay. Here you go. Who's your partner? Oh, hold on. Who's your partner?
Maddie.
Abby? Maddie. Take 1 of those. Okay. Who's your partner? Robbie. Okay. You need 2 of those sheets in front of you. Who's your partner? Luke. Take 2 of those. Oh, you got them. Cool.
I have
You have who? Tanner. Okay. And you got 2 sheets already. Cool. Who's your partner?
Me, Johnny, and Jordan.
Okay. Take 2 or 3 of those sheets then in front of you. And there's your quiz. Who you got, Peyton? Oh,
Yeah.
Okay, that's fine. So take 3 of those sheets there.
I got it. You got them all.
Do you want us to write the identity next to it?
You can if you want. You're not required.
That's it.
I don't know, let me start talking about the big days. Like I had Johnny write it down. And then but then he said you should actually
Mine's in my bag. Yeah, it's all over there.
This one.